So my name is Martin Geddes, and I'm, amongst other things, a network performance scientist. I work with a team of applied mathematicians here in the UK on the state-of-the-art in network performance. And what I want to share with you this evening is the fruits of a coffee conversation I had with Andrew Back and Jeremy Ruston for about 2 years ago. And it started off a train of thought as we realized that there was clearly a new epoch opening up in the world of distributed computing. And maybe the institution needs to rename itself the British Distributed Computer Society. And it inspired us some ideas about how we could bring the kind of inspiration that we received as young people to the next generation, and maybe share some of those thoughts with you and get some of your thoughts and feedback in return as to where we might take this. So here's a little provocation for you. So back about the age, when I was age of about, it's more than 30 years ago, when I was about age 10 or 11, I was inspired by the programs that were on BBC with the Computer Literacy Project. And I used to go into Dixon's, as then was, and start typing programs into a TI 994A until they kicked me out. And my mother clearly realized that in order to keep me out of trouble during my teenage years, she had to buy me a computer. So, so my mother and father did buy me a computer, and this was, of course, the last they ever saw of me as I disappeared into my teenage bedroom. And this is my den. And during those years, I learned to teach myself basic and machine code. And by the time I was doing my A-levels, I was busy designing CPUs from the ground up from integrated circuits along with all their instruction sets with one of my colleagues at school. So I had a sort of, deep and profound interest in computers from an early age. And this carried on. So I got a bit of a CPU habit, and so by my early 20s, I was busy spending every penny I got on more CPUs. My friend went on to be a principal architect at ARM, and it's enabled into a whole career being in IT and telecoms, and I've worked for a number of telcos. So not only did the Computer Literacy Project have a huge and profound effect on me and my whole career, but it's also had a similar effect on many other people who I know and mentioned, so Andrew and Jeremy, who I had the coffee conversation with. So something critical, though, has changed in that time. So in the intervening epoch, all these computers started to get joined together. So for people of my age, there was a period back in the 80s where computers were novel, and we were very excited by them. Now there's a generation of people who've grown up, and for them, not only computers are old hat, but networks are old hat. Networks are no longer novel and exciting. But what's started to happen is that we've now got devices like this, and this is kind of the bastard great-great-great-grandson of the BBC Micro. In fact, in many ways, it has the BBC Micro has a better claim to being a parental lineage of the iPhone than even Apple computers do, because Apple were one of the original investors in ARM. So this is today's BBC Micro, effectively, and the problem with it is that it is hermetically sealed. And as a result, we have a population that is increasingly functionally illiterate in how some of the underlying principles and components of this object actually work. And the nature of the telecommunications industry and the semiconductor industry and not of the IPR and the way that it's structured today greatly discourages people from looking behind the curtain and trying to find out what really goes on with these devices and how they communicate, and to be able to play with them. Now, there's a problem with that, which is that much about how networks work at the physical layer and the packet passing layer is not necessarily obvious and intuitive. And we end up making quite a lot of mistakes a lot of dead ends that we sometimes follow in how we architect networks or build connectivity, because people aren't always necessarily aware of some of the fundamental patterns that are out there and principles. And what I found, actually, surprisingly, is many of the foundations that you might assume exist for networking aren't really there. So the kind of work that, say, Alan Turing did back in the 1930s for computability, there hasn't until very, very recently been an equivalent body of work that puts in place the fundamental theoretical foundations of networking. So we're actually in a surprisingly early part of the development of networking. It's a little bit like the evolution of, say, steam engines, where we built big beam engines for sort of 70, 80, 100 years. And then we worked out, Boltzmann's theory and kinetic theory of gases and Boyle's law, etc. We started to actually understand them properly, and we were able to then start to miniaturize them and build, say, steam trains. We're kind of at a similar place at the moment with networking, is we're at an inflection point where the kind of try it and test it and craft-based building of networks is likely to give way to a much more scientific approach to how we think about these things. And I think the challenge we have collectively is to pass on some of these new learnings to the next generation. And there's a good reason for that. So I'm going to give you just bring this to life, this idea that, it's easy to fall into traps into how we think about networks and literacy about them. So this is a picture of your classic ripple tank from you might remember from your physics lessons at school. And you shine a light, and there's these two little dippers that are vibrating away. And you see that the patterns of, quotes, interference. And we use words like interference or concepts, and we assume that these two devices are interfering, or we need to have certain spectrum policy because it's so easy for devices to interfere. But as we see in the ripple tank, the waves actually pass straight through each other. There is no interference. It doesn't exist. And that the idea of interference is one that we've superimposed afterwards. It was actually our inability to resolve and distinguish the signals that was the real issue. The radio waves didn't interfere. So the kind of example of the literacy gap that exists is the general public believe in a concept called interference. And that has actual concrete consequences in terms of policies you see coming out, things like spectrum management. And the kind of literacy I'd like to be able to see is people to understand from a relatively early age that it's really about the ability to resolve the signals. So it's about how you design antennas, and when these signals reflect off the walls, actually that's more information. And if you have multiple antennas and the right signal processing, actually, you can resolve these, and the interference goes away. And that sets the stage for somewhat of a revolution in how we think about these connected devices. Because at the moment, we impose an artificial scarcity upon ourselves because we have belief in false concepts like interference. So we have to go and divide up all our spectrum into these feudal chunks and then auction them off. When actually there would be ways of organizing ourselves that were vastly more collaborative and can generate a lot more value out of that shared land, as it were. So this is not a unique example. So this is an example of bringing together literacy maybe at that very lowest level of how we think about the transmission. But once we think about beyond the transmission, then we start to compose these transmission objects into meshes and networks. And we see similar fallacies or our language taking us astray in how we construct the higher levels of these networks. So an example of a gap in our literacy around networks is that we treat them as if they do work, network. So we talk about links being idle we talk about best effort, we talk about the power of a scheduling algorithm, and there are all kinds of implicit metaphors that exist in our language around networks. And these, again, have consequences which aren't necessarily good ones for us. So as a result of our belief that networks do work, we've built all our networks using what are called work-conserving queues. So if a link is idle rather than busy, our Protestant work ethic insists that we ought to transmit things because we believe networks should be doing work. And that turns out to be a bad idea. So there's some basic category errors and mistakes we've made. And there's an opportunity to educate the next generation in some fundamentals that today are not well or widely understood. So there's the basic transmission, then there's the things about how you compose these objects that we could teach people about. And that's interesting because the kind of the next revolution or evolution in our industry, just like it was the personal computer, is the personal network. It's about me, the devices I'm wearing on me, the devices that are all around me in this room, and how they collaborate together. And for that to work in scale and be within the boundaries of power usage, etc., we need to be able to understand the true constraints of these systems and not impose artificial ones on ourselves due to the limitations of our metaphors. There are also literacy issues around, say, systemic effects. So what I would love children to be able to play with, the next generation who are in the bedroom equivalent to me, is to be able to put these devices together and understand there's a resource trading space. You can't do everything at once for all the demands on a network simultaneously. To be able to understand that there are regions of predictable operation and there's chaos. If you push the thing too hard, it behaves in certain ways. And for them to get a sort of an intuitive feeling from actually using these things of how they behave without having to wait to become 18 years old and go on an EE course or whatever. These things should come out of the natural action of kids being able to play. And I think that's what, in some ways, the secret of the computer literacy project was it allowed millions of people to go off and play. So I think there's a challenge that we collectively face, which is to prepare the next generation of people who'll be in this room in 15, 20 years' time for a world which will be radically different. So the iPhone I just showed you will be as obsolete and ancient as, say, a green screen terminal is to us today. And the iPhone will have a similar relationship to the world of data around it as that green screen terminal did. 15, 20 years away from now, I think there's a sort of third wave of this revolution, which was, the first one I said was computers were novel. The second wave has been networks have been novel. I'm noticing people I'm talking to now who are in their 20s, they take the networks for granted, and it's all about the sensors, and these little extra objects, which I think we somewhat tritely call the Internet of Things, but that's kind of trying to shoehorn it back into our generation's way of thinking about the problem. So the first thing is I think we have a challenge to expand who knows about these basic ideas and to take away some of this functional illiteracy that exists in the general population about how networks actually work. And out of who knows, you find that there'll be some people who step forward and who care and who want to engage and play. And then out of that, there'll be a small core of people, the people who can. And they're going to be the people who found the next arm or whatever on which very much our society is going to depend upon in its success. So, I've been thinking about, so what and what next. I think there's a number of takeaways. The first thing is I think it's a matter of importance. It's a matter of national importance. Is that Yeah, I and my colleagues get involved in a variety of policy issues and work for big telcos. And we see issues of basic literacy about what networks are causing huge misinvestments of the scale of billions. I think this is something that we need to take a lot. The idea that people don't understand, for example, that networks are trading spaces rather than like pipes, infects the whole of the telecom industry. And that one little gap in understanding causes all the fights over network neutrality and other things that are often utterly futile. So first thing is that this is important. But the second thing is that there are actually things that we can do about it and that are happening today. And it's a question of really accelerating this out into the world. And as I said at the outset, I think for me, what the secret was in getting me to engage in computers for the last 30 years was it started off as a thing I could play with. And we're seeing a number of Kickstarter projects and electronics kits and things out there which let people begin to play with Internet of Things objects, and there's a humidity sensor and a Wi-Fi thing. But what I've not yet seen is any equivalent thing which lets young people grab hold of the real true basics, and play with them and understand them, and go and build objects or play toys that they could take out into the street or the playground and generate new games with, because you're wearing these sensors and you wave your arms around and it does interesting things. But at the same time teaches them, look, there are certain things that radio waves can do and certain things they can't. So I would like to find a way, I don't know how, of finding that entry point, finding that's the place where give it a push and start to spread the word, maybe another Kickstarter project. And maybe it is time that, given the importance that networks and networking have at the personal scale all the way to the national scale, now have to our economy and society, that it is the time for institutions like the BBC or the BCS or others to engage with a national networking literacy project so that we can truly understand how these things work and also escape some of the mistakes is the wrong word. Not to have to think about it in the terms of TCP/IP or technologies from the 1970s, but actually about the true fundamentals that our kids and grandkids will be living with. So that's a little provocation. If you want to get in touch, my name is Martin Geddes. I have a website, I'm easy to find.